Alrighty, so you're done watching Omega Studios segment for October. Now I have your attention for November of 2023. This month didn't see a huge number of headline-breaking discoveries, but it did see a bunch of rather interesting discoveries in ichnology, dinosaur behavior, and the evolution of modern animal lineages. I threw a story about a new dinosaur in there too, for all the dinosaur nerds out there. So without further ado, November 2023. Did birds originate in Triassic South Africa? For the longest time, the earliest form of bird-like animal was Archaeopteryx from Jurassic-aged German rocks. In the last almost 30 years, a handful of other proto-birds have been recovered from similarly aged rocks across China. However, all of these animals are advanced enough to carry a pair of asymmetrically feathered wings adapted for flight, even if that flight may not have been as good as birds today. These theropod dinosaurs and the morphological changes in anatomy from other theropod dinosaurs and into the more advanced true birds shows that the origin of birds is deeply nested within the Maniraptora group, the huge group containing the Alvarezsauroids, Therizidosauroids, Oviraptorosaurians, Dromaeosaurids, Troodontids, and birds, plus all of their weird intermediate cousins. This means their true origin has to stretch back before the late Jurassic, with some molecular studies suggesting an early Jurassic origin. Some experts think they may have even originated during the Triassic. However, there is yet no skeletal evidence of bird-like animals from the Triassic. There is one single purported bird specimen called Protoavis, but this thing has so many problems with it that I don't even want to get into it here. Suffice it to say, the thing is incredibly dubious, and the majority of scientists agree it does not represent what its descriptors say it represents. Okay, so no body fossils. Does that infer something else exists? Well, maybe sort of. Fossil footprints help to broaden the worlds of the past in a way body fossils could never. They help to capture far more animal diversity in a given time and place than bones can. Theropod dinosaur trackways have been known to science for pretty much as long as their bones have, with a good case for their existence being known to human cultures for hundreds to thousands of years. Due to birds being theropod dinosaurs and retaining a similar general foot structure, their footprints look pretty much the same. Fossil footprint experts can usually tell the difference between avian and non-avian dinosaur footprints due to birds having weird arrangements of toes that many non-avian dinosaurs didn't have. But ambiguity can still sneak its ugly face on in there. To that end, there have been bird-like fossil tracks described in the scientific literature for over half a century that have given researchers headaches. Do they represent the true first birds, or are they just non-avian theropods with unique feet? These tracks are called Trisauropodiscus and are known from several sites of late Triassic to early Jurassic age in South Africa. November of 2023 saw the publication of a paper by Mienga Abrams and Emis Bordi in PLOS ONE that takes another look at the previously described Trisauropodiscus footprints to determine whether they should remain as a valid ichnotaxon or be subsumed by the ichnogenus Onomapus, as has been the case for many decades. They found that there were two distinct types of Trisauropodiscus footprints that could represent two different types of animals. Both types come from the Lower Elliott Formation, with one type of footprint being more avian. This they labeled Morphotype 2. Morphotype 2 is said to be very bird-like, but that they don't contain quite enough of the little anatomical markers that confirm a true avian identity. So the researchers hypothesize that these footprints belong to a very bird-like archosaur, meaning that the avian foot morphology originates around 210 million years ago. Birds simply convergently evolved the same foot type. First modern hippos did as the Romans did. The fauna of many parts of Africa today, in some ways, reflect the general faunal diversity that once covered much of the world. Elephants, hippos, rhinos, lions, leopards, giraffes, camels, crocs, pythons, baboons, monkeys, and so many other animals that many of us Westerners identify with Africa were prevalent throughout Africa, Europe, and Asia for millions of years, with many of these groups making it into North America, where they thrived for quite some time. Getting the gist of how these animals evolved into the various forms that are found in the fossil records of these variously happening places can help to better understand the connection between animals and climate. One such example is the presence of hippos throughout Europe for hundreds of thousands of years prior to the last glacial maximum. Their presence indicates the presence of large bodies of water and warmer temperatures, since their skeletal remains don't deviate from the general hippo body plan seen in today's hippos. They've been water horses for a majority of their evolutionary history. One interesting hippo skull from Rome proves that the animals had been thriving in the region for a lot longer than previously thought. A huge team of Italian and German scientists published their work on this skull in a November 2023 +1 paper. A hippo skull was found in the Tor de Quinto area of Rome during the early 20th century, finally getting a description in the 50s. However, the skull was completely removed from its context. So how old it is had to be estimated based on what was already known of hippo evolution, the region's paleontologic history, and local stratigraphy. Most of these Roman vertebrate fossils come from the mid-Pleistocene or Chibanian-aged Valle Giulia Formation, 560 to 460,000 years ago. So that was the general estimate. However, the skull was usually kept out of most discussions on hippo evolution in Europe because of the gray area of its provenance. The new research team took another look at the skull. They found sediment still lodged in some cavities of the noggin, which was the perfect piece of evidence they needed to figure out exactly how old it was and where it had come from. After doing some petrographic and sedimentological analyses on the sediment, they were able to confirm the skull had come from the Montanari quarry, making it Middle Pleistocene in age. The team also did some morphological analyses on the bones themselves and found that the skull belongs to the still-living hippopotamus amphibius species, making it the oldest known specimen of the modern species. Ice Age Australia gets new raptors. Australia has a pretty alright fossil bird record. There's a bunch of flightless birds because, Australia. However, the Australian fossil record for birds from the Pleistocene that aren't flightless birds is kinda lame. There are pretty much only 3 unique extinct species of raptors from the Ice Age: Necraster alasur, Cryptogyps lacertosus, and Dinatoatus gaffae, all of which belong to the Accipitridae family of eagles, hawks, and vultures. Some of this lack of diversity in Australian Ice Age raptors could be due to the wonky climate changes in Australia. It got super dry there during the Ice Age, and it hasn't gotten much wetter since. Other groups of raptors are present today in islands near Australia because they have better climates for them. A paper was published in November of 2023 in Alcaringa, an Australian journal of paleontology, that describes 2 new specimens of raptors from the Ice Age, one of which turns out to be a new species, increasing the Australian Ice Age raptor diversity. The author team reevaluates all of the known Ice Age raptor fossils and fossil sites and describes some new ones. They described some material from the small vulture Cryptogyps lacertosus from Site 7 of the Green Waterhole or Fossil Cave of Tantanoola District, South Australia, plus some more remains from Liana's Breath Cave, Wellington Caves, and the Walleye Caves. They also described new remains of the Australian wedge-tailed eagle, Aquila audax, from the main fossil chamber of the Victoria Fossil Cave in Naraoia, South Australia, dating to the early to middle Pleistocene, about 300,000 to 150,000 years ago. Their huge report also includes indeterminate remains of accipitrids from the Wellington Caves of New South Wales and Liana's Breath Cave of Western Australia. And lastly, they have some remains of what they justify as a new species, Otis pachyosteius, a large eagle that come from the same main fossil chamber of the Victoria Fossil Cave as the wedge-tailed eagle. So, now the Ice Age of Australia has one new bird of prey. Just chicken scratch? Moa is the common name of a group of giant flightless, armless birds related to the still-living tinamous that were the main terrestrial animal in New Zealand until their complete and utter eradication by humans in a span of around a century, about 600 years ago. Somehow. There were 9 species, with the largest standing around 12 feet, 3.6 meters tall, and weighing 510 pounds, 230 kilograms, and the smallest being a bit taller than a large turkey. Their fossil remains are numerous, but their footprints are not so common. Over a handful of fossil moa trackways have been discovered in New Zealand's North Island, but only 2 have so far been found and documented in the South Island. One set of footprints found in Kyburn, Otago in 2019, and a second set of a few footprints alongside the foot bones that made them in 2022 in Pairoa, south of Timaru, South Canterbury. The second set have not yet been described, but a description of the first set was published in November of 2023 by a team of researchers from Dunedin and Wellington, New Zealand, and Sydney, Australia, in the Journal of the Royal Society of New Zealand. The Kyburn tracks consist of 6 footprints that were on average 4.6 centimeters, 1.8 inches deep, 27.2 to 30 centimeters, 10 to 11.8 inches wide, and 26 to 29.4 centimeters, 10.2 to 11.57 inches long. The team collected all 6 footprints by cutting them out of the rock they were lodged in, since cutting out the entire trackway in one piece would have likely been very difficult. In order to even get to these prints, they had to redirect the river that ran over them. After the team collected the prints and did some 3D photogrammetry of the original site, they found that there was a 7th print from a different moa that was bigger, 44.8 centimeters, 17.6 inches wide, and 28.5 centimeters, 11.2 inches long. Because there were no bones nearby, the author team can only speculate as to which moa species left the tracks based on size and what species were alive when they were made, which they found to be around 3.57 to 2.9 million years ago, the late Pliocene to early Pleistocene. The identity that could best fit is supposedly any species from the Camiidae family. The authors hypothesize the genus Pachyornis is the most likely. The authors think the single larger print may have been made by a species from the Dinornithidae family, such as a species from the genus Dinornis. Albatross around the neck of albatross evolution? The vast majority of albatrosses alive today soar on hot air throughout the southern hemisphere, with few making a go at the North Pacific Ocean. Despite this modern range, the crappy fossil record of the albatrosses is at its best in the northern hemisphere. This contradiction tells you that they were once pretty much worldwide. Daniel Kasepka, Alan Tennyson, Marcus Richards, and Robert Ewen Fordyce published a paper on a new specimen of prehistoric albatross in November of 2023 in the Journal of the Royal Society of New Zealand. One of the best-known southern hemisphere genera of fossil albatrosses is Platornis, and it has a long and obnoxious taxonomic history I don't think I want to delve into here. The specimen they described in this paper, chunks of the skull, some vertebrae, some limb bones, and some leg bones, was discovered on a field trip all the way back in 2010 during the excavation of a whale skeleton in the same quarry. After collecting and cleaning the specimens, the researchers found that it had enough unique traits to separate it from all known species of the Platornis genus, so they named it Platornis archaeonautes. This species is the first to preserve parts of the skull, so it shows that this early Miocene-aged genus had a slenderer beak than those of living albatrosses. This is likely an adaptation to a more fish-heavy diet. New dolphin bones, baby! Xenophus is a genus of ancient bizarre-toothed whale, first named in 1923 based on a mostly complete juvenile skull discovered sometime around 1900 in the Oligocene-aged Ashley Formation of South Carolina. Exactly a century later, Robert Boesnecker and Jonathan Geisler published what I would call a monograph on everything Xenophus in November of 2023 in the journal Diversity. Thanks to the discovery of several specimens of the genus both within recent years and some discovered a while ago but that had gone undescribed, the team was able to fully describe and amend the diagnoses of the original Xenophus species, Xenophus sloanii, and then also found that a handful of specimens from a geologic formation above that which revealed the original species' fossils contained enough unique traits to justify a new species. They named the new species Xenophus simplicidens. These animals were like rather bizarre, long-snouted dolphins with echolocation that were unrelated to many of the modern dolphin lineages, meaning convergent evolution was afoot. The new remains showed that these animals were adept hunters, with large curved teeth for sinking into fish, mammal, or reptile, and thickened back teeth for slicing up that prey to ribbons for better swallowing. The new specimens showed that the family group to which Xenophus belongs is a true evolutionary grouping of bizarre-toothed whales from the waters around the southeastern US during the Oligocene. Sir, 2 more dome heads have hit late Cretaceous North America. Pachycephalosaurs, the dome-headed dinosaurs, have one of the worst fossil records of all dinosaur groups. This could be for a whole bunch of reasons. One is that they thrived in environments not suitable for fossil preservation, like mountains or rainforests. Another is that maybe their skeletons were just not great at preserving in the fossil record. Though considering their bone structure wasn't much different from their ceratopsian cousins, this doesn't seem likely. Whatever the reason is, their fossil record is made up mostly of these super dense, thickened bony bosses that capped their noggins. Obviously, enough skeletal material has been found globally to get an idea of what these animals looked like, but the majority of stuff being described these days are just the domes. To that end, a pair of dome specimens, one from the Dinosaur Park Formation of Alberta and the other from the Hell Creek Formation of Montana, were described in November of 2023 by Carrie Woodruff, Ryan Schott, and David Evans in the journal Papers in Paleontology. These 2 specimens contained enough anatomical traits to convince the authors that they represent 2 new species of the genus Spherathalus. For context, Spherathalus is one of the most speciose genera of dinosaurs, with 3 known species before this new publication. Psittacosaurus is still number 1 though, with 10 valid and 19 possible species. The authors named the Albertan specimen Spherathalus triregnum, and the Montana species Spherathalus leesoni. Both of these new species are each other's closest relatives and prove that these animals continued to diversify quite readily throughout the end of the late Cretaceous. Another pick-handed freak. The more birdy the dinosaur, the crappier the remains tend to be. This is not because birdie bones aren't strong, but more so because the hollowness lends the bones to being slowly broken down and disintegrated by natural processes. However, special circumstances allow these sorts of skeletons to be preserved in fairly good detail. One of the many bird-like non-bird dinosaur lineages is the incredibly bizarre Alvarezsaurs. These small theropod dinosaurs are most well known for the adaptation of a highly reduced forearm, ending in usually just one big clawed finger. The earliest forms of these dinosaurs had more normal hands, and then the latest ones just had one big clawed fingy. Most of these dinosaurs are known from bits and pieces, with only some having good to great fossils. One of the best so far was a late Cretaceous Mongolian form described as Jaculinicus yarui by a team of Mongolian scientists in +1. This specimen is pretty much the entire skeleton and shows a small, wispy animal with a toothless, pointy snout for licking up small prey, and only one extra vestigial digit next to the giant claw on its hand. The authors think the specimen was sleeping when it died, as the head and neck were folded over the arm and behind the leg, as seen in some birds today. Poor thing. Did Thescelosaurus dig? Thescelosaurus was a cow-sized genus of bipedal ornithischian dinosaur that thrived throughout late Cretaceous North America. There are currently 5 valid species known to science, with many dozens of specimens. Therefore, they are great critters to use as experimental subjects to understand the internal soft anatomy and behavior of this side of the ornithischian tree. To that end, David Button and Lindsay Zano CT scanned the skulls of Thescelosaurus specimens to recreate the brain to get an idea of how smart these things were, and what they were doing with those smarts or lack thereof. They published their work in November of 2023 in the journal Scientific Reports. They found that Thescelosaurus were not quite problem solvers. Intelligence is hard to quantify or even qualify in extinct animals with no direct living analog, because a small brain may not inherently mean the animal was dumb. Even here, some animals you may consider dumb are still capable of complex social behaviors. Just look at crocodiles. Anyways, the Thescelosaurus brains inferred they had a narrow hearing range, but a super strong sense of smell and balance. The authors used these traits and those of the skeleton, mainly the robust forearms, to hypothesize that Thescelosaurus were good at burrowing. However, their large size meant they probably weren't subterranean specialists or anything, just that they could burrow, and they had the internal anatomy for burrowing. And that was the gist of November of 2023 in paleontology. Unfortunately, whoever was doing November for 2023 was unable to complete it, so I stepped in quite late. Next up is also me for December of 2023, so stay tuned for more me. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching.